In this stream, I will talk about two things. As I said, this will be about the Solana Token Program, where we will follow a blog post by Matt Lim, aka Pencil Flip. And what we'll do is, let me just pull my chat out here to make sure that I can see if someone has a question. So what we'll do, we'll just follow this post. And then following this post, I noticed that in a lot of cases, we had to set environment variables and so on. And then the some of these, these screenshots here, they have, these keys that are, whatever kind of a base 58 string, and it's kind of hard to tell what they are. And so I thought this would be a good opportunity to introduce also a tool that I created at Metaplex called Amman. And Amman will basically help us to not have to set those label environment variables, but instead we can basically pass it label names and we'll resolve those, and we'll see how that works in a second. And additionally, Amman works together with something called the Amman Explorer, which is kind of like the Solana Explorer, except it is adapted to working locally and to give a little more insight into what's going on. And so that would be a good opportunity to understand a little bit more what's going on under the hood here. So first of all, we have to talk a little bit about Amman. So you see down here that I already am running a Explorer. And this is this guy here. This guy is currently not yet deployed, but will be soon. And if you're watching this on YouTube, I will post the link below to where that is deployed. And as you can see right now, it is not very happy because it cannot connect to a local validator. So, which we will do with Amman. So Amman is basically a wrapper around the Solana test validator. Okay, so this one you'll have to have installed. And what I will do is I will right now post a link here in Twitch about the project we're working on. Again, in YouTube, if you're watching this on YouTube, this link will be below. So first of all, you have to make sure that you got the Solana test validator. So it should print as help for you as well. Otherwise, you'll have to install Solana on your machine and you will get that validator with it. Now, the other thing we'll have to look at is how Amman actually works. Okay. And Amman has, for each command, it has basically a help method. So for instance, we can do Amman account help, right? So you can find out about all these commands. But let's look again in summary how these commands work. So you got an Amman start. And so Amman start is what we're going to be using first. And what that does is actually, we'll just show it, okay? So Amman start, what that does is it launches a local test validator. And so we can see that here. And it also launches a relay. And that relay allows us to communicate with the Explorer. So now if we refresh this here, it will be happily connecting. And so the Relay Explorer can, the Amman Explorer will basically connect to the relay to get more information that the Solana test validator itself does not provide. And then from the CLI, we can interact with it also. So for instance, I can say Amman account. And so Amman account will actually ask the relay, are there any accounts that you know of that have been labeled? And it will print those. And right now we are just starting out, so it hasn't anything labeled yet. Okay, so again, in order to get that, you do npm install globally Amman. And as I said, you're going to have a Solana test validator installed first. All right, so now let's look at some other commands here. So Amman stop is basically there in case you forgot in which terminal you ran your Amman. You can just stop it from anywhere. And we'll be using airdrop and label and so on in a second in detail. So first of all, what we need to do, so we're going to go through this post, as I said, and we basically need two wallets first. So we just a quick summary. What we're going to do is we're going to create two wallets, and for each of those wallets, we'll have an associated token account, and which will be associated with a token account, which we also will create. And so we'll mint to that token account, and then we'll also transfer tokens from that token account. And at every step of the way, we will inspect what kind of change, and we'll use Amman Explorer, we use Amman itself, and so on. So the first one, extraction here, is kind of a mouthful. So I will just kind of copy and paste that in here. So let me just go ahead and do that. So basically what this does, it generates a key pair and stores that in a file. And we do the same for the other wallet. So now we have two wallets. The thing is, though, Amman doesn't know anything about those yet. So if you do account, it doesn't know anything about those labels accounts. Also, if you ask Solana about it, it will not know about this yet. Because we haven't basically created them yet. And in order to create them, we'll have to airdrop. So we could use Solana Faucet, I think it's called, Faucet, to do that, right? And it would work, but what we actually want to do, we want to label the account. So I'm going to just copy and paste that in here. Amman airdrop basically does the same thing that Solana Faucet would do, except that it also says, okay, well, I want to label this account that you're going to airdrop to, and that's going to be created as a result. I want you to label that as Solana address 1. So we're going to actually open the Explorer here to show how this will actually change something here in real time. So we'll do that drop, and we can see now that immediately we see some recent transactions updated here, right? And so the recent transactions obviously wouldn't make sense in the Solana Explorer that you know, because in DevNet and on mainnet you would get like tons of transactions coming through. But this is designed, and Amman and the Explorer is designed for local development, and you can actually also control Amman from inside your tests, and even from inside your SDKs or whatever, or your applications. And it's basically meant to allow you to test things locally and see how they work and inspect and so on. So let's open this transaction here. And we can see it got kind of named airdrop 1 sol to sol address 1. And we can see that actually our accounts now are labeled, right? And so what I also can do, this one is going to be the faucet. So I'm going to say that I don't want to have to stare at some long string. Instead, I'm going to just say, I want this to be labeled faucet. And immediately you can see that it updates here. And now we can actually just look through the instruction here. Basically, the system program was invoked, and it transferred from the faucet to our account. Nothing special there, right? Now, but we also need to do the same thing for the other address, just to have some money in there, right? Some sol. And we can see that immediately we get this transaction here as well. And we can see that the accounts are labeled and so on. And now if you run Amman account, right, with no argument, it will, and we have to spell this correctly. So let me try this again. And if you give no arguments, it will actually just list all the accounts that it knows of. And if we do give it an argument, it will print out information about that account. So here we can see this is pretty much what Solana account will do, except here we didn't have to pass this string. We can just pass the label, right? And Amman will resolve it for us. And also what Amman will do, it prints the data, which also Solana account does, but Amman will try to deserialize the data as well. So it knows how to deserialize the token data or mint data. And you can even basically teach it how to deserialize accounts that are part of your custom program. So really useful, and we're going to see how that will help us in a second. The other thing we have to do is we have to make sure that also if we launch Solana comments directly, that it uses this key pair as the pair. So we basically set this in the config, and now you can see that the key pair path that the Solana comment will use is pointing to where we are. We could have also just left off this part here, and it would have just put a relative path in here, but obviously then it only works if we are in the directory, and we want it to work everywhere, so we don't do that. Okay, and now we can basically look into another command here that Amman provides, and it's Amman run. And Amman run will basically just execute the command that you give it. So we say like a double dash, right? And we now actually give it the command to run. So we can, for instance, say Solana balance, right? And then we can say, well, this is a label that I want you to expand. That's why I put a plus in front of it. So what happens now, Amman will actually first expand that label. It will figure out from the relay what that label resolves to, and then it will call Solana balance and we get 1 Sol. So not super special, but it's really useful because now we don't have to remember what these were. We don't have to set environment variables. We can just basically work with the labels as if they were the account keys, so to speak. And now we have finally got to the point where we're going to create some tokens. So for now, we only have 2 transactions here, right? We only created a transaction for each to be airdropped to, and we are now set up. And so now what we can do is we can use the token program, SPL token, and we want to create a token, all right? And we want to set the mint authority to our first wallet, okay? So let's do that. And we can see now that we got another transaction here, right? Now that transaction is not labeled, but we have the signature here, and the token is also not labeled. So if we click on this, we're going to see that the token that we created has this odd address. It's kind of hard to identify. So what we can do is we can actually go ahead and label both of those. So we can say Amman label, and we can say this is a token 1, like we see pencil flip used in this blog. And now we label it, and we can see now that this updated, all right? And we can also name this transaction just to be sure if we look later which one's which. So we can say Amman label, and we're going to say create token 1, but we're going to prefix this with transaction just to separate them. And also what we can see is, so for obviously we're going to have to pass the address. What we can see now is that the TX got converted into this little icon. So if you so it's kind of smart if you prefix something to TX or transaction or whatever, it kind of makes it look nicer. All right, so that's kind of cool. We have our token now, we have our transaction, and we're good. But this is kind of painful, right, to keep doing that. Every time you run a command and it prints out keys, you're going to have to go label them. So there's a better way to do this, and we're going to look at that in a second, right? But for now, we can actually look at our token. So we got the token here. And we can see that, it got actually labeled here, but the actual address is this. We can see what the mint authority is. And again, like Amman and the Amman Explorer kind of shows it in a nice way where you would know exactly what this means. It's not some key that we have to remember what that meant. And the other thing is that what the kind of stock Explorer doesn't have is this resolved info. And this resolved info kind of overlaps with what's up here, but it has a little more information. Basically, it is serialized that token account, the data in it. Okay, so now we can also do the same thing here. And I kind of mentioned before that Amman is smart enough to actually deserialize data even on the command line. So here we print this token. This token actually has data in it, right? And the data basically tells us what the address is. It tells us also what the mint authority is, and tells us all these other things. It's pretty much the same as down here, right? So now where we have that working, we can move on and create the token, the associated token account. I'm just reading down here what's next. So, and now we basically have a token, right? But in order to receive a token, we need an associated token account. So basically an account that for a specific public key, like in our case, this wallet, is able to receive a particular kind of token. So they are associated, right? So what we can do is we could, again, just run the token SPL token command directly. But what we'll do is we'll use Amman run again. And since I did this before, I know that it will first print out when the result will basically include first the address of the token. So I'm going to say the first thing that you see, the first key that you find in the output of the command, label that the associated token account for address 1. And then I can also label the transaction because it will print the transaction key or signature right after. So I can say that, right? And then I can just type the command as usual. And I can say create account. Except it's not quite as usual because, again, I get to use labels instead of actual like long addresses. And I can say I want to create a token account, an associated token account for the token 1, and I want the owner to be the Sol address 1, so the first wallet that we created, right? So I can do that. And let's look what's going to happen. And we can see that it got this transaction and it auto-labeled it for us, because you can see here that so this first address that it printed was what we wanted to label this, and the second one was what we wanted to label this. You can also see that the addresses here got expanded that we passed in, right? And now we can basically go and look into detail into that transaction. So what actually happened when you create an associated token account, right? So there's an associated token program specifically for that. And what it does, it first transfers the amount of SOL or lamperts that it will need for the associated token account to be rent exempt. And that we will pay that from our wallet, right? And then it will allocate the account and will say, I need 165 bytes to store that associated token account data. And then it will basically assign the account to the token program. So the token program now is the owner. And if you have read through the post, PencilFlip talks in detail about how these are associated. For instance, that the mint authority is user space, but the owner here, for instance, the fact that the SOL address is owned by the system program, that's kind of internal Solana. And the fact that now that the token 1 is owned by the token program is internal as well as this assignment here. So once we do this, right, now the token program actually controls the associated token account, right? So we can no longer control this. We could never. And as a matter of fact, I'm going to show the details here, but this account, this public key, is basically a program-derived key or a program-derived address that is specific for the token program and for the owner, like, you know, that was supposed to be the owner of this. And then it initializes the account, and it's done. So now let's look at to show that what I'm actually saying is true. So when we get the pub key for the associated token address, it actually takes our wallet, which is our SOL address 1. It takes the token, right? So this is like the token mint address is token 1, and then it takes its own ID and then the token program ID. So now basically this account now is a PDA, like a program derived address, that will never have a private key, so no one else can control it. And since, as we see here, it assigns it to the token program, like we can no longer control it. So the token program now actually controls the associated token account, but it also controls the token itself, like the mint. Okay. So that's really important to understand. But how can we then make sure that we can still control the account? Well, the thing is that the token program now controls it actually, but we can send instructions to the token program, and we basically, the token program knows who's the owner. So if we sign the transaction, like if SOL address 1 signs the transaction, then we can act. Basically the token program knows that we are acting on behalf of that associated token account, and we have the right to do so. And it will basically do what we want it to do. So we got this. And what else? So now we can actually look at these accounts as well. So let's look at what accounts we have now. So we have the token and we have the associated token account. So if we just look at what's in there, we can see the same that we basically just looked at. Kind of, we see that the owner is the SOL address 1, and the mint that it's for is the token 1. So it basically can receive token 1, and it's supposed to be controlled and owned by SOL address 1, and the token program will basically have to respect that, right? But the actual owner, the real owner, the Solana internal owner, is the token program at this point. Okay, so now what we need to do, we need to actually mint something. So what we can do here, first of all, let's look at what the balance is currently. So if we run MP with Amman, run again the token program, and we are going to look at the balance, and we're going to say, give me the balance of token 1, where the owner is SOL address 1. Okay. And it will tell us that we got 0 so far. If we don't give an owner, by the way, it will kind of print the balance for each one. It will kind of find all the accounts that own this token. And in this case, there's only one, so it shows us the balance 0. All right. And again, we didn't have to specify weird keys because Amman fills that in for us. So what we need to do now, and actually let's look at the, we already looked at the associated tokens, so we're good there. Now, the next thing that we want to do is we want to kind of see like what kind of, how many tokens does this address have in general. So we want to see all the tokens, no matter which token it is, that the that our address has, right? So we're going to do SPL token accounts, and we say, show me all the token accounts that you know, where this one is the owner. Okay, so now it shows us, okay, you know, Solana 1 owns this token and it currently has 0 of it. So basically it has an associated token account for this token, but it didn't even receive any money. That's basically what this says, right? Now if we look for this here, we will find that this is the same as ATA1. So so it owns this token. So this is basically the address of the token it owns, but it owns it via the associated token account. So that's a little tricky to get right. So now what we can do is mint to our token account. So what we can, let me just double check that I'm doing this right. All right. So at this point, there's one thing we can do. We can try to mint this token, but we are giving it the wrong signer. So I'm just going to want to show how this will fail and how this is respected. So if you do SPL token mint this token 1, okay, and 10, and mint it to the associated token account 1, and give it the mint authority, and now we're giving it the wrong one. 2, all right. So we want to. So now this the second address wants to sign this, and it doesn't work. All right. So because we are not allowed to mint this token, because the owner of this token, sorry, the owner of this associated token account is actually SolPair1. So in order to do that, we have to first do this right. So if you do this now, we can say I want to mint token 1. I want to mint 10 of those to the associated token account that I own, and I own it, and I'm signing this transaction here. So now this works, right? We didn't label it, so unfortunately we have to do this now. The recipient is this one. We could have labeled it as part of, if you would have used a label here, but we can label it later. So we can say label, and what would that be? The transaction, right? So basically we mint token 1 to this token account. All right, we enable that. So just that we have some idea here to look at what's going on. So now the interesting thing is, if you look now at Sol address and we look at the tokens, it now has token 1 and it has 10 in it, right? And we can actually look at what happened while this transaction was going on. What kind of instructions did it actually execute? So let's open that. And we can see that it's just basically one instruction that happens. And we're passing in this associated token account. And what actually happens under the hood, that the token program checks whether this actually matches what the associated token account should be, right? It basically, we create a program address on the front end, so to speak, or the SDK, and send that in. But then under the hood, the program verifies again, is this actually a valid associated token address for this owner and for this token? And if so, then it actually goes ahead and mints this token 1. And you can see here that the mint authority is Sol address 1, right? So only this guy can actually mint. That's why it also failed. But first of all, because we gave it the wrong associated token account, and then second of all, because it's not the mint authority, right? And so we can see that, and now we can look at this account and see what's in there. And here we get a little more information. And the cool thing is also that the Amman Explorer actually keeps track of the states that a specific account data went through, right? So the first state was that we had just created it, right? We set the owner and all these things, but the balance was still 0. And then after we just executed the mint instruction, now the amount went to 10, so 9 decimals. So the this is actually, you could think of it as a double, but it's stored as U64. So they basically say there's 9 decimals. So you basically have to divide, or you have to divide by 10 to the 9 or whatever, something like that, right? And then you get the balance 10. And the Amman Explorer figures that all out for you. And if we now, again, we're going to look at our accounts. We can look at this one, if I can type this correctly. Amman account. And we can see that it now has an amount of 10 and all these things that we just looked at. So whatever you prefer, you can look at it in the Explorer, or you can just get it quickly on the command line as well. And now what we want to do, we want to actually transfer. And what we want to do, we want to basically say, okay, I want to transfer, I as address 1, I want to give one of those token 1, I want to give that to address 2, okay? And so what we can do again, we can do Amman run, we can say SPL token, and I want to transfer, right? Token 1, and again, I put a plus here because this will be expanded by Amman. And I want to send one of those tokens to Solana 1, 2, right? Because I want to send it there. And the owner is this guy, all right? So I'm signing this, and this one is the owner. Okay. So now what happens? Well, this one fails because Solana 2, we didn't create an associated token account yet. So Solana 2 cannot receive an associated token, cannot receive token 1. It doesn't have an account for that yet. Someone has to create that. So there's one option to just basically fund the recipient, meaning that we will pay, we will actually have this associated token account be created for address 2, and so we fund it. And the other option is, like, if you don't want to do that, you can actually first have, you can, tell the address 2, hey, you have to, I can send you a token until you create a token account for the token. And so we can actually do that. So let's run that first. So we want to do that step. But this is just one. PencilFlip also shows that option, but fund recipient is another one if you're happy to pay for it. So what we're going to do, we're going to create and so again, like, we want to get 2 labels spit out at the end, right? And so we want to basically already label those. So we can say label that one, and then label the transaction itself, right? Token 1, address 2. So basically what's, I'm just going to run this, and then I'm going to explain with the output. It's going to be easier to show. So we're going to create an account, right? And we want to create an account for token 1. And the owner of the account will be Sol address 2, right? And so that means that we're creating an account in which Sol address 2 can receive token 1, and which also Sol address 2 can basically control. It owns it. Like, the token program will respect that and it will let it control it. So let's run that instruction. And as you can see, that's where the labels were. Like, this is the created account. And then we got the transaction, so we actually labeled the transaction here. So we just have to have the same order, and then things just work. And another cool thing about this is if we do that, we can also script this. So since now we don't have to know beforehand what these addresses are, we can actually, this whole thing I have here as a script. So if you want to kind of try things out, and you don't want to have to manually repeat getting to a certain state, you can just script that part, and then you can start wherever you want to start. Okay, so at this point now, we have, so let's just look at the accounts that we have now. So we have the sorters 1 and 2, we have this token that we're trying to move around and mint and so on, and we have these associated token addresses for each of these wallets, basically. All right. And so now we can actually go ahead and execute that transfer transaction that we were doing before. So let's try that again. So we were going to try to transfer token 1 to Sol address 2, right? And we were going to transfer 1 token. And since now we know that this transaction will basically be part of the output, we're going to label that as well. So we're going to say transfer token 1 to address 2. The thing is though that as part of the output, we'll also see the token that was transferred, but we already labeled that. So we don't want to kind of have to relabel everything again. So we can say only label transactions. So ignore everything else that's not a transaction. Just find the first transaction in the output, because the transactions are longer, so it knows how to figure that out, and label that this. All right, so let's try that. Okay, so we transferred one token. And so what we can do now, we can look at the associated token account. So we can look at this guy, and that should have now 1 in it. Okay, it should have 1 token of token 1 in it. So let's look at that. And we can see that it's minting token 1, and it has 1 in it, balance is 1, right? So now if you go back here, we can also kind of navigate around here, and we can look at that the token balances actually, 1 was subtracted from here and 1 was added here. And we can see the instructions actually not that many. And then we can look at the token, and we can look at the distribution, and we'll now show that Solidus 1 has 9 of it still, and Solidus 2 has 1. And it doesn't, it shows the address, and it also shows the owner. So, when you look at this, you're more worried about what wallet actually owns this, but this is the associated address. And now if you look at the token itself, let me see if I can find that. So if you look at, here we have this transaction, and we're going to look at the token, we can see now in the resolved info, we can see all these states, right? You can see that first there was nothing, then there were 10, and it didn't change that, but we can look at the associated token account. Let me try to find that as well. So this guy, we can see that it has now 3 states, right? Because it went up to 10 when we minted to it, and then it basically went down to 9 because it transferred 1 away. Okay. So, and we can pretty much repeat that. So if we do this again, now you'll see that, okay, now we got a 4th state here, right? Because this one just went down by 1. It now has 8. And we can do this as many times as we want, obviously. And we can then also look at, and by the way, a quick way to find accounts is just to have Amman print out the labels. And I want to look at the second associated token account now, and you can just go in here and search by this. You can't search by labels yet. Maybe I'll add that later, but for now, this is the way to go. We can see that we have 3 of these tokens, and we can see that the different states, right? We started with 0, and then got 1, and then we had 2, and then we had 3. What we also can do, we can show the token accounts that address 2 has, and I'm just going to paste that in here. And we can see that it has this token, right? It has 3 of those. And what we can see, okay, is well, now we don't know what that token is, so we can just run a count again, and we can just look up that it is actually token 1, right? And so the interesting thing that we can see is, like, first of all, like all these states, we can look at all the instructions, and we can also understand how these are related. So what I want to point out again, just at the end here, because we reached the end of the walkthrough, but I want to just point out again what PencilFlip explained really well is that this token account is an associated token account. It is internally owned by the token program, right? So the token program can do whatever it wants with it. Okay, if you send an instruction, it has to actually make sure that the actual owner of this token account, like these kind of user level owner, actually signs a transaction. But the token program now can do whatever it wants with this token account. It can debit, it can do whatever, right? But it also knows that the owner is the Solidus 1. And so the token program itself will actually respect that, and it will actually make sure that whenever we're trying to do something with this token account, if we're trying to transfer away, right? If we transfer to, we don't have to sign. Someone else could transfer to us, but if you transfer away from us, then it makes sure that the transaction is signed by this guy, right? And let's look at the instruction and make sure that actually was the case. So we can see that the Solidus 1 was the signer in this case, right? And you can say, well, if the token program actually does what it needs to do, why doesn't it have to be the signer? Well, it's passed in as an account, but it's not a signer, but because it is a program. And since the associated token address was derived from the token program. Like I showed before here, the token program ID is part of the seeds here. That means now the token program actually, and apart from that, the token program is the owner. It can sign on the behalf of this guy, so to speak. It can basically operate on the associated token account on behalf of whoever, and it has the right to sign. So it can do cross-program invocations, or it can do whatever it needs to do, because it is actually the owner. So it's a little bit confusing, owner versus a user space owner. And that is all I wanted to show for today.